Alright, example 2 for chapter 5, section 1. A loan of $4,000 is amortized with a monthly payment of $100. So first thing we have to do is our timeline. So we have $4,000 at the beginning because again that's our loan. Okay, and again we have this keyword amortized, and then we have a payment of $100, and then a second payment of $100. And then we're going to keep making payments of $100, and our interest rate is 15%, so R is 0.15 monthly. So that means I is 0.15 over 12, and we want to find the size of the concluding payment, and we're going to do two different types of concluding payments down here, but we have some work to do before we can get there. And again, this is monthly, so first payment happens 1 month later, then 2 months later, and on. Now, notice here in this problem, we're not told how long we make those monthly payments. So we have to figure out how many monthly payments of $100 that we need to make. So that's our finding the time part. Now we did problems similar to this again in chapter 4. So we're going to take 4,000, and that's our loan. It's going to be equal to 100 times 1 minus 1 plus 0.15 over 12 to the negative n over 0.15 over 12. So again, we're trying to find n here. First step, divide by 100. 4,000 divided by 100 gives us 40. Multiply the denominator over. Move the 1 over. So now we're getting real close to do the natural log, but before we can do natural log, we have to get rid of this minus. So again, I'm just going to do that in color, just to make sure I did it. And then we're going to take the natural log of this side and the natural log of this side. The power down. So we get that n is equal to the opposite of the natural log of 1 minus 40 times 0.15 over 12 divided by the natural log of 1 plus 0.15 over 12. So there I skipped a step or two, but we've done this more than once, so we should be okay. And entering that in our calculator. So when we do that in our calculator, we get 55 and change. Okay, so that'd be 55 full monthly payments of $100. Okay, now that last payment, that 56th payment, is going to either be the smaller payment, so that's this one, that would be 1 month later, or if we can do it when the last full payment is received, so that would be our 55. Okay, so that's what we're going to look at next. So now that we have everything in a row, we're ready. Okay, so this is the time of the 56th payment. So we're going to do 4,000 times 1 plus 0.15 over 12 to the 56th. And then over here, our exponent's going to be 55. Okay, and then move 1 period forward because we've made 55 full payments. We're finding the 56th payment. So when we plug all of that in our calculator, we get 177 and 89 cents, rounding to the nearest penny. And then if we wanted to make it 1 month later, so that means here we have 56 full payments. And we're trying to find the 57th payment. Okay, that means it should be less than our normally scheduled payment, so it's going to be 1 less. So we're going to take all of this and we're just going to add 1 exponent to each of these. So it's the same setup. Okay, so all I'm going to do is re-enter this and then change my exponents. So again, the first one is going to be 57 now because we moved it one period forward, and then here in our S sub n it's going to be bigger, so we get 80, 11. Okay, so again it's a little bigger but not by much, less than $100, so it makes sense.